So in this presentation, I'll walk through the Citibike strategy dashboard, explain the key insight discovered from the data, and show how this insight translate into practical recommendation to reduce bike shortages and support future expansion decisions. The goal of this analysis is to understand when, where, and why bike demand peaks and how daily bikes can respond operationally. This dashboard analyzes city bike usage pattern across time, location, and seasonality. The analysis focuses on three main dimensions: seasonal demand and weather effect, daily usage patterns by hour, spatial concentration of trips and stations. These insights are used to inform operational decisions such as bike availability, rebalancing strategies, and future station placement. Our first slide is weather and bike trips. Um, what we see here. Here um, we can see pretty much um, the chart compares daily bike trips with daily temperature across the year. You can see a strong positive relationship between temperature and ridership. Trips, as we can see, increase steadily from winter into spring, peak during summer months, and decline sharply during autumn and winter. This confirms that the bike demand is highly seasonal and strongly driven by weather conditions. This is very critical for planning bike availability and maintenance schedule across the year. In the second slide, we can see total bike trips aggregated by hour of the day. Here we can see that bike usage follows a very clear daily rhythm. Demand is lowest during early morning hours, rises sharply around 6 a.m., peak during the late afternoon and early evening, and then decline again after 7 p.m. These peaks align closely with commuter behavior because people are going to work early in the morning and then stay around the city and then they go back home in the evening. The next slide, we can see the most popular station. This is showing us that a small number of stations consistently dominate total trip volume, which is pretty much these three slash five station, which are pretty much all around Manhattan area. So a very busy area. We can see this street, the same street is like W21 Street is recurrent in this chart. This I think is First Avenue probably. Yeah, I think it's Sixth Avenue or whatever. Uh, but this is gonna show us as well from here where we have an interactive map. We have here we can see the density of the recurring bike routes, particularly as I already said, along Manhattan north-south corridors, and of course the waterfront area. This is as a tooltip, so everyone can select whichever trip or direction you want to check. You can zoom in, you can zoom out. Um, but yes, what's important about this chart? It's important because we can see the area of the waterfront area is very busy. Um, and these are not isolated trips, but sustained high volume corridors. So this is pretty much somewhere that city bikes should increase coverage or bikes. Um, what is missing now from uh, this analysis is three very important questions. The first question is how should city bike adjust bike availability seasonally? Well, based on the analysis and the weather and the weather chart and the I think yeah by hours, what we can see that um, I think city bike should scale bike availability down by approximately, I don't know, 30-40% between November and April. The weather usage data show that winter demand is consistently lower across almost all station and time periods. It's very important to maintain full summer capacity during winter would be inefficient and increase unnecessary operational cost. Instead, that period can be used for bike maintenance, repairs, and fleet optimization. Second question, very important. How should city bike decide where to add new station? So a new station placement, as I already said before, uh, should be they should be added along the Manhattan area, the waterfront area. Um, yeah, should be guided by high volume route analysis rather than evenly spaced station expansion. If we have to install new station, I think this area is the area that really needs more coverage. This map is showing us clearly high density recurring corridors along Manhattan waterfront and north-south travel routes. This corridor indicates sustained demand rather than one-off trips. Adding station in these areas will directly support existing high usage patterns and reduce congestion nearby stations. The last question that we have is how can city bike reduce shortages at popular stations? Well, if we see the weather and the bike trips by hour, as already said before, bike shortages can be reduced by prioritizing the dynamic rebalancing during peak demand hours. Um, the hour user chart shows clearly peaks during morning and evening commuter times. Additionally, the station ranking analysis show that a small number of stations consistently dominate trip volume across all seasons. These stations should receive priority for staffing, bike redistribution, and real-time monitoring. Final conclusion: we need to pay attention exactly to all these temporal, seasonal, and spatial analysis that are supporting improved data-driven operational decision by aligning bike availability, rebalancing strategies and station expansion with actual demand patterns. DV Bike can reduce shortages and improve service reliability. These recommendations are directly supported by the data visualized through the dashboard. Thank you very much.